Like wind and hydroelectric power, embedded solar power is an inexhaustible energy source. Inexhaustible energy sources are similar to renewable, but can't be used up no matter what happens. Here's a key word: photovoltaic, meaning relating to the production of electric current of the junction of two substances exposed to light. The solar energy is absorbed into a photovoltaic cell, which is a small part of a solar panel. A cell is composed of a layer of glass, a negatively charged phosphorus semiconductor, a junction, and a positively charged boron semiconductor all above a base. The junction holds the electric field from the semiconductors, and when a photon pushes an electron free, the electric field will remove the electron from the silicon-based junction. Metal conductive plates transition the removed electrons into transferable power. The photovoltaic effect was discovered by Edmund Becquerel in 1839. Here's a solar-powered calculator. The first non-scientific solar-powered calculator hit shelves in 1976 and was really society's first example of a solar-embedded product. Embedded solar energy is solar energy being integrated into everyday products. This power bank is embedded with photovoltaic cells that charge a battery, which can then power any devices compatible with USBs, ranging from phones to speakers or cameras. When you search Amazon for solar-powered devices, there are over 7 pages of options, including power banks, solar-powered security cameras, keyboards, ultrasonic pest repellents, solar-powered toy car kits, flashlights, motion sensor security lights, backpacks, Bluetooth speakers, emergency radios, and even automatic watering devices. On the less practical end, there are solar-powered flushometers, and there's even a solar-powered talking Bible. It just goes to show you the versatility that solar embedding has in products. Up next, we have an example of a solar embedded device that is directly translated to mechanical energy. The infrastructure requirements are housed within the device. In general, the only requirement is that they do not draw a lot of amperage. Smaller, lighter weight batteries will be key for making embedded solar products more usable and more efficient. To that effect, a surprising discovery published in 2016 by Organic Electronics found that researchers successfully produced solar cells that are only 1.3 microns thick, only 1% the width of a human hair, and 5% the weight of a sheet of standard paper. It was also determined that the cells are so light that they can sit on a soap bubble, but also produce energy with approximately the same efficiency as the larger glass-based equivalents. A key technological breakthrough in the future will be the use of floating solar farms. Known as photovoltaics, these arrays of solar panels will cover large bodies of water, reservoirs, or dams. Great benefits to using these include not wasting valuable land and a greater power production by up to 10% because of the cooling effect by water. Napa Valley, California is home to the first photovoltaic when it was installed in 2008. We need to find a way to produce energy without polluting the environment, especially without CO2. Solar, wind, and hydroelectric power might be able to provide enough energy if they are produced and installed in sufficient quantities. Embedded solar energy is just a start to a cleaner and safer environment for our lives and the lives of future generations. Do your part by lowering your carbon footprint through using inexhaustible energy sources.